This is the second lesson of Unit 5, and we're going to be looking at algebraic expressions, and we're going to be involving factoring as a way to simplify them. So simplifying rational expressions, again, simplifying we've talked about, and factoring is a way to do that. Rational is referring to fractions. Expressions means we don't have an equal sign. So how do we do this? Well, the first thing we're going to do is we're going to go back to what we started with yesterday in factoring. So I'm going to move this up. I'm going to focus right on the denominator. So am I able to factor this? So 1 times negative 12 is negative 12. I'm looking for two numbers that multiply to equal negative 12 combined to equal negative 1. That'd be negative 4 and positive 3. X minus 4 and x plus 3. Because the leading coefficient is a 1, I don't need to worry about doing bottoms up. This is equivalent to this, and here we already have x minus 4. So when I look at both sides, I'm looking to make sure first that I have a common denominator. This is the denominator of the left and denominator of the right. Now on the right hand side, I can see it's missing an x plus 3 if it's going to have a common denominator. So x plus 3, and to keep this fraction of the same value, whatever you do to the bottom, you must do to the top. X plus 3. Okay, so both of them have an x minus 4 and an x plus 3. On the left hand side, I have a 7x, then a subtraction sign, and then I have 3 plus 2x times x plus 3. If I zoom out here, it may be a little bit easier to see. So I'm taking what I had in the numerator on the left, bringing down the subtraction sign, and what I had on the right. And I'm going to go through and I'm going to FOIL this. So front, outside, inside, last. Multiplying the front. So I'm only going to write down right now at this time the numerator. So 7x subtract. And I want the subtraction sign to be applied to anything behind it. And for that reason, I'm going to put down a bracket. So here we go. Multiplying the front to get 3x. Multiplying the outside to get positive 9. Inside is going to be plus 2x squared. And last is going to be plus 6x. Now I'm going to combine like terms here. And put it in standard form. So I have 2x squared, 3x and 6x, 9x plus 9. Okay. And now I'm going to distribute that negative sign to everything inside. 7x minus 2x squared minus 9x minus 9. Multiplying like terms, I end up with negative 2x squared. Okay, positive 7x and negative 9x is a negative 2x minus 9. Now we do always have to see, is it possible to take this numerator and to factor it? So do we know two numbers that multiply to equal positive 18 and combine to give us a negative 2? 1 and 18, no. 2 and 9, 3 and 6, no, not possible. So there's the numerator, and then the denominator. We do not have to FOIL the denominator. Do not do that. This is equivalent to this original expression. Example number 2. Feel free to press pause, write it down, and then press play. Okay, so what are we looking for here? And there's different ways to do this. So I'm looking for what is the smallest number that both 5 and 10 divide into, and the answer is 10. So in order to create this, to make this a 10, I need to multiply it by 2. So here's 10. I have 10 on both sides. And now I need x squared. So if this already has an x squared, this doesn't. It needs one more x. So now I have 10x squared. Whatever you multiply to the denominator, you must multiply it to the numerator. Okay, so on the bottom I have 10x squared. And on top, if I move this to the side, and on top I have negative 10 plus 2x. Now on top, I'm able to divide here by 2. So this can go one step further. Divide by 2, and I end up with, and if we can rewrite the order, negative 5 And I don't really care for that. So what I'm going to do is I'm going to switch the order here and put a 2x in front and negative 10 in back. Because the order you write these in when you're adding or subtracting doesn't matter, as long as the sign stays the same. What I'm trying to say is negative 10 plus 2x is the same as 2x minus 10. So I'm going to factor out a 2, and I'm left with x minus 5. So here's what I have on top. Here's what I have on the bottom. Numerator and denominator. Can we go any further? We sure can. 2 and 10 I'm able to reduce. 2 divides into itself once, 10 divides into 5 times. So I can go a little bit further here. 2 divided by 2 is 1, and you wouldn't have to put a 1 out front. 10 divided by 2 is 5. This is in fully reduced form. Sometimes students ask, can I reduce the x's? There's 1 on top and 2 on the bottom. You can't do that because this goes together. X minus 5 is a group. This is in fully reduced form. Example number 3. So I'm going to start out by factoring. I can see a difference of cubes. This is going to break into 5x plus 4 and 5x minus 4. This cannot go any further, and the last one cannot go any further. So when I'm looking for a common denominator, I can see 5x plus 4 and 5x minus 4 is the common denominator. That means this is missing a 5x minus 4, and this is missing a 5x plus 4. Whatever you attach to the denominator, you must also attach to the numerator. Okay, each term has 5x plus 4, 5x minus 4, 5x plus 4, 5x minus 4. So down below I can write 5x plus 4, 5x minus 4. Now I have just a singleton 2 on top. Then I have x times quantity 5x minus 4 plus 3 times the quantity 5x plus 4. So I'm going to distribute this negative x and this positive 3. And then I'm going to combine like terms, and I put it in standard form. So there's only one term that has an x squared, 2 terms with an x, and now let's see, can we factor this? All right, so I'm looking, first of all, is there a number that I can factor out of negative 5, 19, and 14? And there is not. But I know that 5 times 14 is 70. So these two multiplied equal negative 70 and combined equal a positive 19. Okay, let's see if there's anything here that works. So 1 and 70, no. 2 and 35 is not a difference. That doesn't work. 70 is not divisible by 3. Not divisible by 4. It is divisible by 5. What about 5 and 14? Okay, so 5, let's see here. 5 times 14 is 70. Now this is where it gets tricky. In order for it to equal a negative 70, one of these would have to be negative. So it could either be a negative 5 or a negative 14. But it can only be one of them that's negative. So for instance, a second here. This multiplies to equal negative 70, and this multiplies to equal negative 70. But in doing so, knowing that only one of them is negative, neither one of these combinations will combine to give us a positive 19. So this is not factorable. So what do we do with this? Well, this is in the numerator. I'll rewrite it neatly off to the side. And on the bottom, I have 5x plus 4 and 5x minus 4. Please let's leave it in this form. Please do not FOIL this out. Example number 4, again focusing on the denominators. So what multiplies to equal negative 6 and combines to give us a positive 5? Oh, that would be positive 6 and negative 1. Let's check. Multiplies and combines. So plus 6 and minus 1. And I'm going to put an x in front. I know it's just one x because when I take this number and divide it by 2, it's x to the first, x to the first. So it's x to the first and x to the first. Don't forget what a lot of students do, and they forget to put a 2 on the bottom. x plus 3, and now this shifts up, and 2x minus 1. So I have factored this trinomial that's in the denominator. I'm going to do the same thing over here. This would be positive 2 and positive 3, so x plus 2 and x plus 3. That's the denominator of the right. This is the denominator of the left. Well, let's see what they have in common. They both contain an x plus 3. Okay, so they both contain one factor of x plus 3. Now the left side has an 2x minus 1. So I also need this on the right hand side. Whatever I do to the bottom, I must also attach to the top. Okay, so they both have 2x minus 1. And on the right side, we have a factor of x plus 2. But I don't have that on the left. So I need to attach an x plus 2 and an x plus 2. Okay, so now we're set. We have the denominators. We have a common denominator. Down here, I'm going to write down x plus 3, 2x minus 1, and x plus 2. On top, I'm going to come up here, and I'm going to take time really quick to to distribute this. I end up with 3x squared plus 6x. And I can do the same back here, but remember, we're not just distributing a 2, it's actually a negative 2. So negative 2 times 2x is a negative 4x. Negative 2 times negative 1 is a positive 2. Combining like terms, I have 3x squared plus 2x plus 2. Okay, let's see, is it possible to go further with this? So when I look up here, I'm going, is there two numbers that multiply to give us 6? Multiplied to equals positive 6 combines to give us 2. 1 and 6, not a difference of 2. 2 and 3, not a difference of 2. That means that I have fully simplified this rational expression. Example number 5. Okay, starting at the bottom here, and 1 times 4 is 4. Looking for two numbers that multiply to equal 4 and have a difference of 4. So what multiplies to give us 4? 1 and 4, but it doesn't equal 4. 2 and 2 does work, so x plus 2 and x plus 2. If I FOILed this out, I would end up with this expression. Off to the right-hand side, I can see this is a difference of cubes. This is x plus 2 and x minus 2. What do they have in common? Okay, well, they both have one factor of x plus 2. They need to be exactly the same. So this has two factors of x plus 2. That means you need to attach an x plus 2 to the right-hand side. Now they both have two factors of x plus 2, but the right-hand side has a factor of x minus 2. So x minus 2 on the left and x minus 2 on the left on top. Whatever you attach to one side, you must also attach to the top. The bottom and the top need to be the same if you're attaching anything new. Okay, so I can see what the bottom is. It is x minus 2, x plus 2, and x plus 2. The order you write these in does not matter. Now on top, I have 4x minus 1 times the quantity x minus 2, and then negative 3 times the quantity x plus 2. I'm going to FOIL this top. So front, 4x squared, outside, minus 8x, inside, and last. And now I'm going to distribute the negative 3x minus 6. This is just the numerator, and now I'm going to combine like terms. This is the only squared. Okay, now I'm looking for all the x's. Negative 8 and negative 1. That's negative 9. Negative 12x, and positive 2 and negative 4 or negative 6 is negative 4. So before we see is this factorable, I can see that 4, 12, and 4 are all divisible by 4. So I'm going to factor out a 4. That's correct. That's correct. And that's correct. Now, is it possible to come up with two numbers that multiply to equal negative 1 and somehow combine to give us a -3. That's not possible. So what do I do at this point? Well, I have the numerator. I've simplified it as far as possible. And then the denominator was our common denominator. This is equivalent to this original expression. This problem seems easier than the first 5 examples, and yet a lot of students get confused because they're like, well, they both have an x, I just need to add a 3 and subtract a 2. These two go together. They're almost like a couple. Where this x goes, there has to be a +3 with it. So this is missing an x plus 3. Whatever I attach to the bottom, I must also attach to the top. And this is missing an x minus 2. Now I can see the bottoms are exactly the same. Okay, let's look. Let's look at the top here. So I have x times x is x squared. X times -2 is -2x. Okay, and I have a positive 4 times x plus 4x. Positive 4 times 3 is plus 12. Okay, so x squared plus 2x plus 12. Now before I put this on the bottom, let's see, is this factorable? 1 times 12 is 12. Are there two numbers that combine to give us 12, a positive 12, and the difference is positive 2? Let's see, 1 and 12, okay, the difference is not 2. 2 and 6, the difference is not 2. 3 and 4, the difference is not 2. Okay, that means this is not factorable. So there's the top, and the bottom is x minus 2 and x plus 3.